thing though before we get started, and I think it's actually really important when you do a kind of a competitive study of somebody else. I think it's just incredibly important to state a disclaimer. And first of all, I am by no means a database expert. I've used databases. I'm familiar with databases. I kind of understand the features and the functionality and capabilities. I could talk about them. I don't code databases. You know, we've got a whole group of engineers here at Cockroach Labs, some software engineers who are doing some incredibly great and impressive software engineering work. And those are database experts. You know, software engineers create the data or create the tools that we all use typically. And so I am not that. But however, I can actually glean information from as many sources as possible. And that's what I've done here. You know, from all the presentations that I could find, you know, at reInvent or stuff that's available in the docs, you know, from the Amazon or the AWS pages, and then just by using the database, my own personal experience. And so, you know, it wasn't actually easy to actually collect all this. I think sometimes when you are a large organization, you have lots of different versions of a database and all these things. Sometimes things get a little bit muddled, but I'm trying to distill what I've learned into some salient points that I think all of us can be better educated on. And I'm not saying I'm right or wrong. And so I think that's really, really important because I'm not an AWS engineer. But as I stated before, I am forever impressed with great software engineering. And there is some amazing engineering that's been done by the AWS team. This is not some sort of teardown of them. This is not some sort of like, let me rip apart, you know, an approach. I think there's a lot of different approaches to the cloud and to delivering infrastructure software in the cloud. And I just wanted to point out some differences and some limitations that we see that our customers are coming to us for to actually to solve. Now, I am an employee of Cockroach Labs. I am a believer in our team and our approach. I think, you know, the very first time I met Spencer, our CEO, about 3 or 4 years ago, I knew I had to work here because, you know, I'm a real believer in terms of, you know, the future of the database and what that architecture needs to look like. And that's what I want to present here. And we'll kind of talk through some of these things. So sorry to give all this disclaimer up front, but I find it really important to kind of pay respect to, you know, some really great work that's being done by the AWS team. And by no means are we looking to kind of tear them down, right? And so I really want to call out what's cool here and really paint a vision of the future of what I think, you know, the cloud database reality is ultimately going to be. So I'm a little ahead of myself in my slides. So, okay, so great. So, you know, why are we talking about all this? And, you know, like, just got to start at the top level. I think as we build applications today, as we each of us sit at our desk, you know, we're dealing with some really unique requirements that have emerged over the past 2 to 3 to 4 years. And you know, I've been in the big data space for a while. I was at a company called Hortonworks and Hadoop and all this stuff. And this big data thing has been around for about 10 or 12 years or so. But we're being asked to like deal with these things, but deal with them in all types of applications, not with just AI and ML and data science, but like with our transactional applications, right? And that's been going on for the past couple of years. I think we've turned to things like Cassandra to do these sort of things, right? We need efficient scale and distribution. You know, scaling our apps, we're required to do so. They need to be available everywhere, and they need to be always on. And honestly, our users expect low latency access to these applications. Now, what's happened over the past couple of years is we have turned to the cloud to deploy these applications. And the cloud is fantastic. It has delivered a lot of great things for us, from an ease of adoption, speed, from a cost point of view. I no longer have to have a server room in my building or in my office, right? I don't have to hire a whole group of people to do all these things. There's economies of scale. And they are good for resilience and scale and availability. However, when it comes to our applications, the way we run software on top of this public cloud infrastructure, there are some realities and some very big challenges. We're using legacy software on top of the cloud. And a lot of this legacy software simply just wasn't built for the cloud. And it's leading to us missing SLAs in terms of not being able to deliver a great experience to customers. Or, you know, we don't have coverage, or we're not able to control where data lives across, a large public cloud infrastructure in global formats, right? And so, you know, the database itself is kind of this top layer of infrastructure. We think about the public cloud typically as servers and instances and load balancers and IOPS and all that stuff. But I contend that infrastructure does not end in hardware. Infrastructure actually ends at the operating system, and then typically for our applications, that surface area is the database. And I think the cloud database is really the future of where things all move. If you look at kind of other adjacent areas, we see things like in data warehousings, that sort of stuff. And I think that's kind of just where things are going. Now, for me, architecture really, really matters in the cloud, right? I think, this, like I said, the cloud hardware is going to do these things, but it's the software that lives on top of this hardware and these platforms that really needs to take advantage of these things. Now, if I look back over the last 10 to 15 years, and my career over the past couple of years has really been in the cloud native space, I just think there's one company that got this before all of us. And kudos to, all of the work that was done at Google over the past 15 years, 20 years, whatever that's been. Because they showed us how to run distributed systems at scale. They were the cloud company before everybody. In fact, I was at another company called CoreOS before I was here at Cockroach Labs, and there was a guy by the name of Brandon Phillips, who's a kind of a luminary, a real kind of great expert in the whole Kubernetes space, and a founder of that company. He used to call Kubernetes and this kind of push towards distributed systems Google infrastructure for everybody. What is Giphy, he called it, right? And I think that's where we're all kind of moving, or it's all where we want to be. But Google did this, and it was like kind of their own cloud. In the middle here is something called Borg. Borg is like the back-end orchestration platform that does this. Now, from a data point of view, Google has lots of different solutions, Bigtable, BigQuery, all these things. But from a transactional, relational database point of view, they actually built their own database, and it was called Spanner. So they kind of had this kind of layered approach to things. And so they had hardware, they had this orchestration, they had data and infrastructure living on top. So where is all this today, right? Well, today for all of us, right, for us mere mortals, well, we're looking at the public cloud providers, right? We're looking at GCP, Google. We're looking at AWS to provide these instances, right? We're looking to Azure. Now there's others, the DigitalOceans of the world doing fantastic jobs. Maybe you're running it on bare metal at Equinix. There's lots of different options there for how we do this. And we actually want to run these things on-prem as well. What seems to be happening to me, though, this middle layer is becoming kind of now been simplified from Borg into Kubernetes, which is kind of a descendant of Borg. And for us, well, a little small commercial before I start. CockroachDB is a direct descendant of Google's Cloud Spanner. So I think this architecture and this emerging kind of world, ultimately, if it's Cockroach or something else, being a distributed database on top of these orchestration platforms, I feel is really the future. And is that a year out? Is it 3 years out? Is it 5? Is it 10? I'm not really sure in terms of timeframes, but I do feel we're living in the future here, and this is the ultimate outcome. And when I said I saw the future of the database, it is a distributed SQL database. And I think there's lots of different cloud databases that are doing different layers of distribution. And that's what I want to talk to today, right? Because I believe that architecture really, really matters. Now, real quickly before I go on, somebody was asking if the recording is going to be available. Absolutely. We post these things to our YouTube channel, the Cockroach Labs YouTube channel. They're usually up within an hour or two. I don't want to give an SLA on that I'm not the person who does it. So they will be up there today. All right, so let's talk about Aurora, and let's talk about, if I'm going to say architecture matters, let's talk about the architecture of Aurora before we kind of compare the two. And along the way, I'll point out a few different areas where we've seen some limitations of Aurora along the way. But I want to be as fair as possible here. Now, Aurora is ultimately a version of Amazon RDS, right? Relational Database Service, RDS, right? Now, our Amazon RDS has several different flavors, MariaDB, Oracle. You can run a single instance of a database in Aurora pretty well. Now, that's just basically running a legacy database on, in their infrastructure. That's great. Now, Aurora was really built to kind of help with scale and resilience. And there's really kind of two flavors of it. There's MySQL version of it, and there is a Postgres version of that. Now, there's a couple other variants of AWS Aurora. There's global database, there's multi-master, and there's serverless. We'll talk about each of these variants a little bit later, but I want to talk about the basic architecture of Aurora first, under the covers. How does this actually work? Now, again, it takes a little bit to actually get here. Now, Aurora this is from them, a cloud-based relational database engine that combines the speed and reliability of high-end commercial databases with the simplicity and cost-effectiveness of open source databases. It is absolutely that. What I feel, if I break it down and I give a simple statement about the architecture, what they've done is they've taken, if you think about a database, there's really three layers. There's the language, there's an execution layer, and then there's a storage layer. And any database can really be broken down that, right? What's my API? How do I interact? Is that SQL, right? I think everybody will agree SQL is kind of the lingua franca of relational databases. For execution is how do I execute writes and reads, and there's do I have a cost-based optimizer in there? I'm looking at queries, right? Because your SQL statement actually gets broken down into a whole bunch of sub-transaction statements that are actually happening in the database itself. That's SQL execution. And then ultimately, data gets stored to disk. And those are really the three layers. Now, what I feel the basic explanation of Aurora is they have Postgres and MySQL on top from a language and an execution point of view. But underneath the covers, what they've done is they've created a distributed storage layer. And so from there, that's how they're actually getting this distributed nature. Now, I look at it as kind of this picture on the right-hand side. What they have is they have various different endpoints. And these endpoints, this write node, this read node, each one of them are instances of, if it's MySQL, MySQL, if it's Postgres, they are Postgres. Each one of them are instances. They are running on top of something that is this storage layer that is a collection of machines with solid state devices. They're spread across multiple AZs, and the data is written 6 times across all of these different storage devices. And that's how they're actually distributing the data. I'll come back to that in a little bit. The trick here is they have decoupled everything, right? Instead of writing locally in this write node, they're writing down to the storage layer. And the storage layer is then writing multiple different times. Instead of reading or finding the node where this data is written, I just ask the storage layer can return it. So you kind of think of it as a pool with multiple different execution engines sitting on top of that, right? That's kind of the simplest way that I think about this, and that is a distributed storage layer. Now, they're doing some really interesting things at the storage layer. When Aurora writes, they're actually doing 4 of 6 quorum writes. So they're writing data 6 times across, they'll write it, twice in each AZ, and it's an intelligent storage layer. And they actually require 4 of those 6 writes to commit before they can actually commit a transaction, right? They do this and they write it multiple times so they can actually survive the failure of an AZ within a single region, right? Because still I have 4 versions of the 6 available. And I can still get a quorum write if 2 of the 3 availability zones go down, right? I still have 4 copies of that data. So reads are guaranteed when 3 writes are written. That's separate than that, right? So writes are 4 of 6, and then reads are guaranteed when you have 3. I can say nothing other than this is brilliant. And whoever came up with this, and I'm not sure who it is, I really tried to find out the engineer's name leading into this. And if there's anybody from the AWS team on, if there's a group of you, I'd love to know the names of these guys, because this is actually pretty brilliant. This is taking open source technology, an open source database, and re-architecting a layer of it to be distributed so that I can actually gain some really, really huge benefits of it. I love it. I as a software engineer, again, it's a really unique approach to thinking about a difficult problem. It addresses both scale and resilience. However, I feel it's limited in that it's really tied to a single region. Now, they've done some things around global database, and I'll come back to that in a minute in terms of how you can actually get multi-region Aurora. But let's just go through each one of these things. So let's talk about scale and resilience, right? So in order to scale one of these instances, you want more reads? Well, you just simply add more Postgres instances, endpoints, basically on top of the storage layer. It's great, right? It's pretty simple, right? If a node fails, if a read node fails, fine, just load balance and go ask a different, endpoint, and it's still going to have this data. The data pool is still all there, right? And so, from a scale and resilience point of view, for reads, it's pretty good architecture. Now, this is where I'm going to start to get into some issues with Aurora from what I see. And so, sorry, I forget to share. Thanks. Somebody just actually posted into the chat the design decision for 6 copies in Aurora. Thank you so much, Stephen. That's exactly the kind of stuff I was looking for. I wish you were here when I was building all this stuff. So let's talk about writes. So if you want to scale writes, actually you're limited. You are limited to a single endpoint for writes. All writes in Aurora need to go through a single endpoint. And what we've seen with several of our customers, we've seen customers actually shift from Aurora to Cockroach because of this problem. It ends up being a bottleneck. It's like a single instance of a database. You can only scale as hard or as high vertically as that server can, right? The hardware can, because you can't have multiple write nodes. You can't scale horizontally for writes, and that is a big limitation for Aurora. Now, we're going to talk about this in terms of global database as well, which is actually pretty important as well. And then resilience for writes. Well, so what happens if the write node fails? What happens is it takes a read node. It's smart enough to actually take a read node, spin it down, and recycle it back up as a write instance. And so in terms of what's going on until that write node comes back, you basically have a few seconds between the spin down of that read node and it coming back as a write node. So you can imagine this second node here would have come back as, spin it down and come back, right? And so there is RPO. I think it takes some of the documentation. It's hard to tear. I think it's a 5 to 10 second downtime for RPO for writes. And so that's another kind of place where there is some concern. You may miss some transactions in that time frame. So so that's a little bit about basic Aurora from a scale and resilience point of view. Now let's talk about transactional consistency. This is something that's near and dear to Cockroach. We talk a lot about this. It's something that we deal with a lot in our database. Since Aurora is just simply using MySQL or Postgres on top of it, well, it just adopts all of the same settings that you would have for isolation, be it read committed or serializable or whatever you want to do in that database. And by default, it is set to read committed. Now, look at, I was a developer. I never thought about isolation levels in a database. It's just not something that I think about. I don't think many developers think about this. I have a couple on the phone that have told me that they never thought about this. So by default, you are set to read committed. If you wanted to guarantee transactions, you should set that to serializable. And then in read committed, you're just getting snapshot isolation. So possible issues with that. There's lots of data issues. We actually have an old webinar that talks about data issues that are associated with isolation levels. Non-repeatable reads, phantom reads, you're reading something that wasn't there. Under heavy load, however, tracking of serializable transactions can be exhaustive. This is just a memory pool limit in Postgres. It's a configuration thing, and actually can kind of tire out in that single write endpoint, right? And then there's another one that we actually ran into, and again, I'm going to talk about this later. Benchmarking and running tests. I feel like I could sit here and tell you all day long about, what our team and our member of my team, Sean, ran on these things. But when we were actually testing ourselves versus Aurora from a TPCC with a 10,000 warehouse workload, there was a whole lot of, the entire database seized up once we introduced any sort of workload contention. So if you're familiar with that benchmark, go ahead and try to run it and check out the workload contention issues that we have seen within our own tests. I know people get around these things somehow. I'm not a database expert, so we'll go there as well, okay? So now let's talk about Aurora as a global database, right? Now, what they did is a few years back, I think about 2 or 3 years ago, yeah, it was 2 years ago, the team introduced this new version. And what it did basically is it said, hey, look, I want to introduce additional endpoints in additional regions so that I can actually reduce the latency it takes for people to access data. Because if I had deployed a version of Aurora and it was just in, US West, well, if I have a person in Singapore and England and all of it, they've all got to go to US West to get that data, and you can't beat the speed of light. And so they wanted to actually address some of these things around dealing with, access to data. Now, what happens here is you have data is still being written in one region and then synchronized out to other secondary clusters or secondary instances of Aurora. Initially, this was just what you were only able to have one secondary, but they have since changed that over the last year or so where they can have multiple different, I forget how many it is. It is limited to, I think, 5 or 15, I think maybe, or I think it's 15 read instances. Regardless, you can cover fairly the planet with this. There's some issues here though as well. And I use the word global here because honestly, I don't think this really addresses a lot of the global concerns that we see with our customers and the reason we built Cockroach, right? So let's think about it from a scale point of view. It still has some issues, right? So as you use asynchronous replication from, the primary out to all the secondaries, there is a delay. There is reason to have eventually consistent, right? One second here. So there is reason, there is going to be some eventually consistency, because look, when I write in one memory pool of storage, it's not instantly written all over the place. There is going to be some sort of delay. So you will have inconsistent transactions at moments. And then also, this doesn't solve the write latency issue. You still have a single bottleneck, single endpoint that is a write. So if I'm writing data and I'm in England and I'm in Singapore and I'm on the West Coast, I'm still dealing with the speed of light issue, of which actually is significant, especially when you're doing complex transactions. If the round trip between, say, Singapore and LA is 100 milliseconds, you're going back and forth a couple times, there is a delay in that, and it can cause issues in applications. Now let's talk about resilience a little bit. Let's upon failure of region. I'm sorry, there's a couple things that are going on in the chat at the same time, y'all, so I'm trying to pay attention to both. So now let's talk about resilience. So one of the other reasons they introduced global databases is they want to be able to have a failover from, a regional failure. Now what happens is, what they do is since the storage layer is actually done, they can actually fail a region, the entire thing can come down. And what happens is the secondary region will be promoted as primary, and one of these nodes will be promoted to a write. Now, this takes time. It's well over a minute for this to actually rebound and come back. And still, you're going to have issues with writes because you're still going through one single place. Now, let's talk about how you recover from this, because it's one thing that there's a failure of a region, right? And so once the primary goes down and the secondary comes back up, how do you actually make sure that the two regions are correct? Now, you have a layer of storage that maybe you've recovered on one side and a layer of storage on the other side. You now have to remediate the differences between these two things, or you're going to take that entire storage layer and move it into the primary. Now, that's expensive because now you're dealing with movement of data costs between regions. And so typically what will happen, you need to remediate the differences between these things. So depending on how long it's been out, you have a fairly difficult situation to get that actually the primary that went down back up, right? And so that's typically an issue that we see in customers as well, and a big problem. Regional failures happen. We've seen it a lot over the past couple months, y'all. So these things happen. Everything fails, right? So then let's talk about compliance. And I bring this up. I don't think a lot of people think about this, but we do a lot here at Cockroach Labs. We built a feature called geo-partitioning, which allows you to tie data to a particular location based on some data within that row. So if I want all German records to live in German servers, I can do that. And I'll show you a little bit of that a little bit later. When you do this with your application, there's a lot of privacy regulations that require you to do this. We do it because we like to break down latencies. We like to have data live closest to users. Maybe I don't want to incur, this egress cost of the asynchronous replication. Can it just live in a region where I need it, so I don't have to actually pay for it to actually propagate to all the other regions, right? Get pretty expensive when you start thinking about how large that storage layer gets, right? So ultimately, there is no capability within Aurora to tie data to a location that I'm aware of. I believe that if you want to do that, it's at the application layer. And again, if somebody wants to tell me in chat or QA, happy to answer that. So again, really, really difficult. And then if you do want to comply with regulations, well, you need to set up an instance. So, all the endpoints, each one of these things, these stovepipes within each region. And then you're ultimately just managing different databases. So really, what have you gained, right? You're now have this complex, different instances in different places. How do you remediate that? How do you bring stuff together to do, science in it? How do you do end-of-day queries across all of them? Like the complexities of running multiple databases in multiple different regions. I think we're all pretty well aware of that, just from a resource point of view, and then how you deal with that. We think of it differently, and we'll talk about that. We just think of the database running all over the place as a single logical database, and let the database deal with where data lives, right? And so again, there's costs here. There's privacy regulations, and that can actually lead to costs. Some of these regulations, like GDPR, have teeth, and so that can actually get pretty difficult too. And then finally, the cost of just replicating data between each of these regions can escalate pretty quickly if you think about how large your storage layer is, especially as you're writing data 6 times in each one of these instances. And so, look, this is going to be something that I think everybody needs to think about. I think as we become more cloud native and as we think about data living all over the planet, I think we all need to get much more efficient and intelligent about where data lives and how we move it around, right? Egress costs are no joke, right? And they can actually escalate pretty quickly based on what you're trying to do. And so I think this is definitely something to look at as you're thinking through Aurora Global Database as well. Okay, let's see, not a whole lot of questions here. And the team has been, I think, pretty engaged. So thanks, guys, from the back end. That's great. And then, all right, so I talked about the basic Aurora. I talked about Aurora Global Database. Let's talk a little bit about Aurora Multi-Master. And I only have one slide here. And you know, the knock that I had on basic Aurora was that, you know, this single write node and it's a bottleneck and it's this stovepipe, and that's kind of a difficult. You can only scale it as high as you can go with the server that it actually runs on, right? And so Aurora and the team introduced something called Multi-Master. It was, I believe, last year at reInvent. It was a beta feature. It is out there and available. I think it's still pretty limited in terms of what you can do with it, in terms of what will run underneath it. But the limitations that I see are tremendous. It takes away all the value of Aurora. I think they designed it for only certain workloads that aren't going to scale reads, but just writes. And honestly, it really is limited because you can definitely only run it in a single region. So you're still dealing with latencies across the planet if you want to do that, right? And then if you implement multi-master, you can only have 2 write endpoints on top of this distributed storage layer. You cannot have anything else. You can't have 3 writes, you can't have 4, from what I understand. And if there's somebody from the AWS team, please tell me. And then you cannot have any of these read endpoints as well. And so you basically, what's on this picture is exactly what you're going to get. It's 2 write endpoints and that's it. Still pretty limited. From what I understand, the consistency between the 2 write endpoints is good. I think you can still get serializable. From what I understand, I'm again, if somebody has some insight into how they've implemented the consistency model for isolation of transactions across these 2 write masters, I would love to see it. The presentations and stuff at reInvent aren't that great in explaining how they've actually implemented that. I mean, we could go through the transactional model in Cockroach. Go read the life of a transaction in our docs pages. It goes through intricate detail how we've actually implemented this. And it's pretty cool stuff, actually, from a software engineering point of view. Again, every time I talk externally, I talk about our docs team, and our docs are extremely valuable. So please go check them out. Pretty awesome stuff. So, all right, so that's all the stuff about the kind of the architecture of Aurora. And so for me, I believe that you can't just simply rework a layer of the database. You can't just take the storage layer and redo that, because it's going to lead to all these issues. And you know, getting multi-master going so that every node can be both read write, that's going to take the execution layer to change, right? Dealing with latencies and tying data to a location so that you can actually meet compliance, that's an execution thing, right? And so you've got to kind of go up the stack. The one layer that I don't think needs to be redone is SQL. I'm just a firm believer that SQL is the lingua franca. That's what developers use. That is a relational database. I think about relational, I think SQL. And I find it as just a pure requirement, right? And so for me, a cloud database ultimately will need to be re-architected from the ground up. And it has to be distributed, not just at the storage layer, but at the execution layer as well. Now, I'm going to go a quick run through of Cockroach. Now, we have an entire other webinar. I think I did it last month in December about the architecture of CockroachDB. It's an hour long. It gets really deep into lots of different nooks and crannies of the product itself from a software engineering point of view. And I would highly suggest that if you want to deep dive. This is just a high level overview because I wanted to actually go through the high level stuff to compare the 2, right? And so if I think about scale, First of all, well, I just spoke about this. I mean, ultimately, Cockroach is a relational database. It implements SQL, so it's familiar for your developers, get up and running pretty quickly. But ultimately, underneath the covers, it is just a cluster of nodes. And these nodes are all connected via TLS, basically, and they coordinate with each other. They rebalance, they replicate. There's a lot of magic that's going on across multiple different instances of Cockroach. If I want to scale, I simply spin up a node, I point it at the cluster, and the cluster itself rebalances things, right? And so this is how I don't have to deal with like any manual sharding anymore. It's just going to basically, increase the volume of the database, but I'm also going to increase the volume of write transactions as well, because every single node in Cockroach can accept both reads and writes. And so we aren't going to ever have this write bottleneck, because I can ask any node, I can ask this node over here for data that lives somewhere else, and it's going to be able to get that within this cluster. Now, when we write data to Cockroach, we're actually writing data in triplicate. It's configurable. You can go, 5, 7. It's as long as it's odd. We're doing quorum writes as well. So 2 of 3 nodes actually have to commit a piece of data. So you are actually writing data in triplicate, but data may live all over the place. Any node in Cockroach is a single consistent gateway to the entirety of the database. And that's how we're going to be able to scale both reads and writes, which is actually pretty important and directly, against this whole kind of write bottleneck thing. And we've seen customers come to us because of the write bottleneck problem. But I can scale further. We can scale to as many regions as you want on the planet. We can have, we can have nodes running in multiple different regions. Again, I can ask any node for data. It's going to be able to find it anywhere it runs, right? In fact, we excel in this type of environment. I'm going to come back to how we can tie data to location as well. But if you think about that, well, that's regions, right? That's US West, Central, and US East. Here's one thing that we can do that there's not another database I'm familiar of that can do this. If you wanted to run on-prem and in the cloud, a single logical database. So again, any of these nodes can access data both that lives on-prem or in the cloud, whatever. You can do that with Cockroach, and purely a multi-cloud database, a single logical database spanning multiple different cloud providers, which is pretty unique. I mean, you just think about each one of those different, instances or as a region, right? And so we can actually do that as well. So single logical database. And that you talk about Aurora, let me come back to that for a second. I mean, there's a little bit of a lock-in thing here. You're kind of tied to that infrastructure. Any of the cloud provider databases, that's what you're going to do. I think that's kind of where things are going. I don't want to talk too much about lock-in. I think we all deal with it. We all understand our own risks, tolerance for that, and what that actually means for us. So that's really up to each individual organization to deal with. But we kind of like that we can actually be truly a multi-cloud database, like truly multi-cloud. We can actually survive the failure of lots of different things. We can survive the failure of a node, a rack, an availability zone, an entire region. Cockroach is configurable to do this. When you actually implement Cockroachers, typically when you implement a database, you think about the logical model of the database itself, what tables and referential integrity and keys and indexes and all these things. You still think about that. This is simply SQL. This is Postgres. We are wire compatible with Postgres. So again, it just looks like Postgres to the application of the developer. But ultimately, when you implement Cockroach, you got to think about 2 things: resiliency and latency. And what do you want to survive? And at each table, you can actually survive any way you want. So we can actually write data to a cluster so that maybe there's 1 copy in each region. Maybe all copies live in 1 region because I want the consistency or the tie data to a location. At the table level, you can define this, but we can survive basically the failure of an entire region because the data is still available. And the database is smart enough that if it's offline for 5 or 10 or whatever you want to configure so long, and if I only have 2 of 3 replicas, it'll actually create a 3rd version of a replica so that it's available anywhere. And again, deeper dive into the architecture in another webinar, right? And so what we're looking at is it's always on, and kind of another unique feature of this, we can do something called rolling upgrades. We can actually have multiple different versions of Cockroach running on all these different instances. We're backwards compatible 2 versions, so I can have v19.2 and I can have 20.2 all in a single cluster. And for us to upgrade, we just spin one down, spin it back up, and it's going to participate, and it's going to consume that that temporary under replication and then downtime, right? And so it's pretty cool that we can actually do that as well. We just simply shift users to another region or another node or whatever that is. So we can really survive whatever you want to survive in terms of failure. And then, finally, this is that unique feature I kind of talked about before, but being able to tie data to location, to me, is a critical requirement of being a distributed system. This is how you actually attack things like latency at global scale. If I have everything running in one region, again, the Singapore, New York, England, whatever that is, really, really difficult. At Cockroach, this is a part and parcel of the way that you configure each table. In fact, we can change this on the fly at each table, a simple alter table command, and I can actually change where data lives. Say I have instances of Cockroach running in Germany and Portugal and Sweden, and all of a sudden I bring up some instances in Italy, say, and I had the Italian records, we're living in all those other servers, but I want to make sure that all my Italian customer records are in these new instances. I simply add a new location and identify those services where that data needs to live. And the database redistributes that data so that all those records are on those new servers. It allows us to do some really cool things around putting data close to a user, and then what a lot of people like to do with is dealing with compliance and some of these regulatory compliance things that are going on. So, all right. So then finally, let's compare price. Now, this is difficult to do. I don't find it fair to do this. I think everybody's kind of application and implementation is going to be a little bit different. And it's always funny. We get these questions like, oh, can you compare price? And our sales engineering team, a lot of them are on the phone with me right now. We need a pricing calculator, and everything's going to be different. And the reason it's really different, let me just show you a couple different things here. And so if you want to look at, if you want to look at Aurora pricing, go check out their pricing. There's lots of different variables here. You have to actually choose your instance, the size of that machine, right? You've got to go through, or you want a reserved instance, whatever you want to do there. Lots of different choices here. You got to think about storage and IOPS. You got to think about your backups. Backtrack is a feature that allows you to basically do point-in-time restores of data. That's just another cost. There's a snapshot exports, each one of those costs, and then there's the data transfer. So all this egress cost that you're actually dealing with, think about that as you start to think about, asynchronous replication between zones. And I'm not saying I think everybody needs to deal with this, and there's a lot going on here. Now, for us, we kind of simplify pricing, especially for Cockroach Cloud, down to here's your size of machine, here's the storage, and then there should be IOPS in here as well. We can give you the information about IOPS as well. Now, there's a couple of different things that we'll tune with you to get right, but we're trying to make things as simple as possible. Now, I still think that comparing price is one of the things that everybody should do. Again, I can't really get deep into it. Ultimately, I think getting a TPMC number for these things. So if you're familiar with the benchmarks like TPC-C, getting cost per transaction actually is a really interesting metric. We've done this. We've published a couple of blog posts about this. It's in our blog row. I'm not going to get too deep into those because ultimately, again, as I started, I'm not an expert in Aurora, nor is anybody in my team. They can tune Aurora better than I can tune Aurora. We can tune our database damn good. And so anybody who's going to show you a benchmark and show these things, I always bristle a little bit at them because I think it's ultimately how well we're going to set you up for success. And there's lots of different costs. And there's a whole other presentation about the total cost of a database that might be interesting for you as well as you start to think about price and what that actually means for you. So finally, we do have a web page where we're a little bit more punchy in terms of why us over Aurora. And I talk about some things, but in there is kind of a quick 2-pager, which gets into a little bit more detail in terms of some of the things that are different between the two databases in terms of at the feature or capability layer. And so I would highly recommend going check that out. Some interesting comparison chart there, and a little bit about this architecture that we're talked about. But I like to really basically break it down into really the 4 areas which we focused on in this presentation today. I think for scale, Aurora is pretty good in a single region. Again, you're only going to be able to scale rights as far as you can in that single instance. So I think in a single region, it's pretty good. When you start to get to anything global, though, there's costs associated with replicating data all over the place. There's this single write instance, which you have latency issues. I think we've architected a database that's going to scale both reads and writes. We're going to deliver low latency access to data. We were built to be global. Really, we are spawn of Google Spanner. Spanner was built to deal with these issues as well, right? From a resilience point of view, I think, for reads, again, it's pretty good on our Aurora side. I think for writes, again, we get this bottleneck and you have this issue. You have one endpoint. For us, active all the time. We're going to get RPO down to 0. You configure the database at the table level to define what you want to survive. And so you have a lot of granular control over what you're doing. And, you aren't dealing with any sort of active passive system. It's all active. And so that's kind of a unique advantage of CockroachDB. From a consistency point of view, in a single instance, single write node, you're going to have these isolation levels that you would have in Postgres or MySQL. But once you get beyond that, again, you have the limitations of scale and resilience. We are always serializable. We guarantee transactions in CockroachDB. Again, if you want to look at the transactional model we've implemented, the distributed execution model that we've implemented, go check out our docs and check out the life of a transaction page. I think it does a really good job walking through that. We have, again, there's an architecture presentation from last month that does a decent job showing you how we do that. But because it is a single execution engine for writes, you're never going to get this distributed execution. And so guaranteeing consistent transaction and distributed execution layer is difficult. And some really awesome software engineering work done by the team here at Cockroach to really push the envelope in that, right? Locality, no capability, to geo-partition or tie data to location. Again, it's just like a legacy database. You're relying on developers to do that. And then if you want to, or you just have stovepipes of data, we automate that. I went into that fairly intensely. And then finally, from a cost point of view, I'm not going to give you a cost comparison one way or the other. I'm happy to do it with you in an engagement and walk through all of these things, but I think there's just way too many variables. But there's a lot of options. We try to be as straightforward as possible in our pricing and as transparent. I will tell you that, especially with Cockroach Cloud, I think one thing I didn't talk about earlier, but is actually pretty important. With Cockroach Cloud, every customer gets a full level of support that we give everybody. So if you have issues, there's a phone and to call. There are SLAs associated with issues that we are on the hook to actually deliver for. When you get a contract with us for Cockroach Cloud, and that's for all of our cloud customers. So you are getting support. It's not some extra add-on thing you have to buy, and that is an add-on expense with a lot of the AWS services. And then we're there to make you successful. We've hired an incredible group of SREs that are managing all of our clusters, with thousands of clusters running in Cockroach Cloud, and so. I think this is one of these areas of cost that is undervalued or underestimated or not thought of, I guess. I don't know, but a really important one. And so, and then, there's all the other Slack channel, and our docs are great. I would put our docs up against anybody. And so I think there's all kind of stuff that's related to those sort of things. So with that is the end of my material. One last commercial for us. We are a general purpose database. We work for all different types of workloads, system of record, general workloads, whatever that is. We can actually run in a single region, in multiple regions. Cockroach Cloud is really the easiest way to get started with Cockroach database. And we're happy to work with you and talk through any of these details. There weren't I think a lot of the questions were actually answered in the chat and the QA. I thank our team here, Daniel, Chris, and Tim, for doing all that. And again, I think people were asking about latency and numbers and all these different things. Yes, benchmarks. Again, I am happy to go through that in detail with you all. We do have a couple of blog posts that are on that. I know people were looking for that. I just wanted to go through architectures and show some of the issues of these other things. So with that, I don't see much more coming in. I think the team is asking. Let me see here. In case for multi-region clusters. So there's a couple pretty intense questions here about how we deal with transactions in multiple different regions. And under high transactional write loads is one of the questions that we had. And do we need to actually synchronize how we acknowledge, writes? The underlying transactional model actually is looking for, quorum rights. We use Raft, we use MVCC to do all of this. And what we're doing is we're ensuring that all transactions are gaining that 2 of 3 rights across the 3 different replicas that are written in Cockroach. Somebody was asking, how do we deal with this synchronicity and the latencies involved with that? There's a lot of interesting things that we've done from a software engineering point of view. One of the things that we implemented, it was in 20.1, it was the first time it was released. We implemented a feature called parallel commits. Now, when we first introduced this feature, I remember Kyle from Jepson he was on some presentation. He was like, and then some black magic happens here where the transactions happen really quickly, and he didn't really understand it first. We actually sat down with Kyle, and there's some really interesting things that came out of that. But we wrote this feature called parallel commits, which basically is kind of the way I think about it is you can't bend the speed of light in a database, or you can't bend the speed of light, but you can actually change the photons that are being, shuttled around. And so we're able to do some really cool things. We're pipelining transactions in the database at a deeper layer, but we're also doing this thing called, parallel commits where, if I commit on one instance or one node, one replica, and I can look around that and say, hey, this is the state of that. And I can send basically the state around that record and that transaction over to the other side. And as long as everything looks about the same, I can actually, with a fairly good confidence, say, yeah, I'm going to acknowledge this back before everything actually executes. I can actually do this thing called parallel commits. Now that is a marketer's version of some really awesome technology. Our team led by Rebecca Taft wrote a SIGMOD paper that we published, I don't know, 3 or 4 months ago. That goes into a little bit of a deeper explanation of how that kind of genius works. But again, some really interesting software engineering, just as all these teams are implementing. And so that's some of the ways in which we deal with some of these latency issues when you start talking about synchronizing transactions across, broadly dispersed nodes of Cockroach in different regions. So with that, I'm going to stop this webinar now. I'm tired of talking. I don't have anybody else on with me today, but I wanted to thank everybody for joining. I hope this was valuable. I hope I gave a little bit of insight in terms of, some of the architectural differences between the two. I want to thank everybody, but most importantly, can you please complete the post-event survey? I'm very interested in hearing the feedback from this. This will help us direct what we need to do next time. I think people were asking for numbers. Maybe we just have a whole session, we'll just go through numbers. Again, lots of caveats in that, but we're happy to do that as well. And so suggestions and comments and all of that is very much appreciated. Again, I want to thank the team on the back end for answering questions and dealing with everything. Tim, Chris, and Daniel, thank you guys. And thank you everybody for taking your time today for joining us. A recording will be available and up on our YouTube channel, Cockroach Labs YouTube channel, in the next few hours. Thank you and have a great day.